All right, so problem 1. The sum of two numbers, x and y, is 2 pi r cubed. And we are asked to find the two numbers if one of them is 2 units greater than 4 times the other number, and x, y, and r are real numbers. All right, so supposing we let x be the smaller of the two numbers, where y is that number which is 2 units greater than 4 times x, as described above. Well, then we can denote the sum of x and y as 2 pi r cubed, as follows, and simply do some plug and play to obtain the value of x, given what we know about y. And after a few basic algebraic steps, we get x equals 2 pi r cubed minus 2 over 5. And therefore, all we need to do is plug in this known value of x into our equation for y, and we obtain the following result. And we obtain a value for y that is quantity 8 pi r cubed minus 8 over 5 plus 2. Okay, and all that's left to do now is simply to show that the sum x plus y does indeed yield 2 pi r cubed. Okay, problem 2. Solve the system of cubic equations. And so all we've done here is we're reassigning our solution for x above the name y sub 1, and our solution for the number y above will reassign the name y sub 2. Okay, so the implication here seems to be that there is in fact a solution for s, and we can find any such possible solutions by setting y sub 1 equal to y sub 2 and solving for r. So let's go ahead and do that. Needless to say, there's going to be a variety of possible steps that you can take here to solve for r. But the main objective, of course, is just to isolate r on one side of the equation, where r represents the x value at which the graphs of these cubic equations were to meet in a coordinate system. Okay, so before we go any further, let's have a look at the graphs of these two equations. Okay, so we know that both of these equations are cubic equations, which suggests that their graphs, respectively, will take the form of some S-curve. So let's go ahead and plot y sub 1 and see what that looks like. And let me point out quickly that we are going to graph both of these equations in terms of x cubed as opposed to r cubed. And the reason for that is that if we use r cubed, if we use r as the sort of independent variable in Grapher, it's going to actually give us the equation of a circle. And so when Grapher sees the r in there, it's assuming that we're trying to plot the equation for a circle, which we're not. We're trying to plot a cubic equation. And so we're going to substitute this here r for x. So we have y sub 1 equals 2 pi x cubed minus 2 over 5. All right, and let's just center origin and zoom out a bit. All right, so there we go. Okay, so that's y sub 1. Let's go ahead and add equation y sub 2, which is 8 pi x cubed plus 2 over 5. And there we go. So we see, indeed, the system of equations S has a solution at this point. And what we're going to want to do is simply verify that we've computed the correct values. Or value for r. So graphically, we just want to know the coordinates for this point of intersection. The way we do that in Grapher, so we go ahead and we select both equations. We just go up here to equation in the menu bar and find intersection. All right. And that's the value. That is the x value for this point of intersection. Okay, so we have minus 0.5965. Minus 0.5965. So that is the x value. Okay, and so let's just go ahead and quickly make sure, because we're mathematicians and part of our job is to think about, verify, and validate that computer-generated solutions map and match with our sort of symbolic calculations. All right, so let's go ahead and vet this solution. And what I'm going to do is I'm going to do that in terminal. Okay, I'm going to invoke Bash's basic calculator with long precision. And I'm going to go ahead and say minus 2 divided by, okay, because We're going to have to do this in 2 steps. No big deal. Afterwards, I'll show how to do it in Apple's native calculator. But we'll have to do this. We'll evaluate this. We'll evaluate r in 2 steps using our calculator, and we're going to start with the radicand first. Okay, so we'll evaluate the radicand, and then we'll go ahead and take the root of that value. Now, the way bash handles pi, because we're not in a computer algebra environment, so we're not using, say, SageMath or Mathematica or Maple or Maxima or any of those, MATLAB. We're just using bash. Okay, so we're just using bash, and so this is useful for anyone who, is perfectly comfortable using any of those computer algebra systems, but maybe doesn't have one downloaded, and so we don't want to jump around between applications, blah, 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 blah. So we're just going to use bash. Now, the way bash handles pi, okay, is through an expression invoking the arctangent of 1. Okay, and so bash has a number of functions built in. Cube root function, unfortunately, is not one of them. In any case, we have this workaround because, and so since the arctangent of 1 is pi over 4 radians, the following expression can be used to obtain the value of pi. So, of course, going back here quickly to the denominator of this radicand, so we have 3 times pi. All right, so we have 3 times, and now the value of pi. And so again, it's this expression here, 4 times the arctangent of 1. Okay, is essentially the value of pi. All right, let's see what we get. Great. Okay, so that is the value of the radicand. And so all that's left now, and again, all we're doing, just as a reminder, is double checking the x value of this point of intersection. So all we need now is to take the cube root of that radicand, and we're done. And we're expecting to see this same value here. Okay, so bash does not, like I said, I think I mentioned, bash does not have an inbuilt cube root function. So if you want to use bash as a calculator, you'll have to write your own. I wrote one in C++ that I'm going to invoke in just a moment. If you'd like me to do a short video on how to write a script of that kind, I'd be happy to do that. But you can find them online. It's pretty straightforward. So I'm just going to go ahead and navigate to where I have that particular program. Okay. And it is in the file cuberoot. All right. And I need to compile the program. So C++. All right, no errors, no issues. Program is compiled, and now I can call it. All right, and so it's basically just prompting me to enter the radicand, or the value of the radicand, which I've computed up here. So we're just going to take that and see what we get. Perfect. All right, so the cube root of this radicand, right, is minus, right, is minus 0.596467. Okay? Rounded to that particular decimal place. So I think it squeezes out one more decimal place. Let's see here. 1, 2, 3, 4, 5, 6, 2, 4. So I got 2 more decimal places here. All right, so great. So those two in agreement. Great. So then all that's left to do now is substitute this value for r in either of the equations, y sub 1 or y sub 2, to obtain the value of y at this point of intersection. Same deal, we're just verifying now this value here, the y value at which the point at which the graphs intersect. And then we're essentially done. So let's go ahead and do that. Okay, so let's set up our equation environment. We have y sub 1 equals quantity 2 pi r cubed minus 2 over 5. And then we simply follow the rules of arithmetic. Minding order of operations. We can eliminate the radical sign. And 4 pi over 3 pi reduces to 4 over 3. And then finally, we're left with minus 2/3, which in decimal form, of course, is minus 0.66. And we're done. And so now we have both coordinates, x and y, the point of intersection. And therefore, the system of equations S has a unique solution at coordinates minus 0.5965, minus 0.6667, rounded to the 4th decimal place. Okay, so I'm going to post the script for the cube root function in C++ in my GitHub, and I'll link to it in the comment section below. If you have any questions, let me know, and I'll see you in the next one.